Hello, my name is Professor Rad, and in this video, we will walk through writing an equation for an ellipse. So right now I'm working in Microsoft Word, so I've just got some pieces here to help me out with this process. For writing an equation of ellipse, it's not always necessary to graph it, but I will just so we get in that extra practice. So the information they've told us is one focus and the vertex and the center. So let's graph the information they've told us first. So we have one focus at 3, 0. So I'm going to move this over to 3, 0. A vertex at -4, 0. Interesting. And then we're centered at the origin. So let's go ahead and graph the center at the origin. Well, it's not quite centered there, but we get the idea. Okay. So in this information they've told us, they have indicated where the major axis is because the major axis runs through the foci and the vertices. So I'm going to graph my major axis. It's the x-axis here, since it's running through those pieces. And that means the minor axis is the vertical direction. So the minor axis is going to go along the y-axis. So I'm just going to sketch these out here. What is going on with this line today? Microsoft Word. I don't want to be in a pain. There we go. All right, so we've got our axes sketched and some of the components. Now, actually, we do know how to plot the other vertex and the other focus. So we know how to do this because the foci are always located between the center and the vertex. So here's my center, and here's one of my vertices, which means a focus should be in between there. And the foci have to be equidistant from the center because the center is in the middle. So since this focus is 3 units to the right, the other focus is therefore going to be 3 units to the left. So the other focus is here at -3. And then you can use the same process for the other vertex as well. So this vertex is 4 away to the left. So that means this vertex is going to be 4 away to the right. So we can get those pieces in, and we can start to envision what this ellipse is going to look like. So I'll just bring this friend over here, and we know that we're like that. Now there is a problem here in how I've sketched this ellipse, in that I can't actually sketch this yet because I have no idea how tall or short this ellipse is or should be when I go to graph it. I mean, I can kind of maybe get a sense, but in order to really know that, I have to figure out how big the minor axis is. And sometimes they'll give you that information, but in this case, they didn't. So we're going to have to work it out. So let's get some space to work it out in, shall we? So for an ellipse, remember that the largest distance is a. So that means we're going to have a squared is b squared plus c squared. So that's our formula we're going to use to help us figure out that minor axis. A is the distance from the center to a vertex. So in this case, A is going to be 4. And C is the distance from the center to a focus. So in this case, our C value is going to be 3, since the foci are 3 away. So now that we have A and C, we can use them to figure out B, and we need them to figure out B because we have to figure out the equation. So A is 4, so 4 squared is 16. And C is 3, so 3 squared is 9. So if I subtract that, that should give me 7 is B squared. And so B is going to be the square root of 7. Oops. All right. Now, I didn't bother to find B here. I just wrote it as B squared because really in the equation, we're going to need B squared. not so much just b. So let me move some of these pieces up a little bit to give myself space for the equation. Now I'm going to grab a calculator real quick and figure out a decimal approximation of the square root of 7. So it's about 2.6. So that means these points are going to be at about 2.6. Now these points are clearly too big for me to use to be useful. So I'm just going to bring my ellipse here and graph it so that the top is at about 2.6 and the bottom is at about negative 2.6. So we're estimating here as best we can, but that's a pretty decent picture for our ellipse. So that would be our graph. Again, ideally I would have my actual points plotted here, but because of the way Microsoft Word is working with me today, these are a little bit too big. All right, so let's get to the pièce de résistance, which is the equation of our ellipse. So as I recall, for the formula of an ellipse, what is happening here? We're going to have some fractions. So we're going to have x minus h squared over something squared plus y minus k squared over something squared, and that's going to equal 1. So this is our basic format. To figure out whether I have a here or b here, or b and then a, I look for where the major axis is. So since the major axis runs along the x-axis, that means that x gets associated with a, the larger value. So that means I'm going to have an a squared here, and then y gets associated with the b. So this is our general shape of our equation formula. Now we just plug in the pieces. What's different about an ellipse from a parabola is that the h and k are not a vertex because we have 2. So which h and k would you use? But the h and k refer to the center. So here our center is the origin, which means h and k are 0. So that's fantastic. So that means this will just simplify to x squared and y squared. A is 4, so 4 squared is 16. And then this is why I really just need a b squared to be 7. So I'm going to write 7 here. Now, if you prefer, you could write 4 squared and root 7 squared if you would rather have that in your denominators. And you could write x minus 0 and y minus 0. That would totally be fine as well. This is just the most concise way of writing this equation. I'll also point out, notice that c does not factor into the equation at all, so we don't see in the equation, but it is there in secret because we needed it in order to find b. Okay, so don't discount c just because it doesn't show up in the form of the equation. We still need it because it helps us find the other component. All right, so there you go. That's how we can graph an ellipse and also use that to help us write an equation for the ellipse. So in the next video, we will be identifying features of a hyperbola, moving on to the last type of conic. So looking forward to seeing you then. In the meantime, I hope you have a wonderful day, and bye for now.